Algebra practice midterm. Number 1A. Complex numbers. 2 plus I in parentheses times 3 minus I in parentheses. Okay, the first step we want to do is we want to distribute the parentheses. So we start with the first term 2. We multiply 2 times 3 and then 2 times negative I. So 2 times 3 is 6. 2 times negative I is minus 2I. Next, we distribute the second term, which is I times 3, and then I times negative I. So I times 3 is just plus 3I, and then I times negative I is just negative I squared. After that, we want to combine the imaginary terms negative 2I plus 3I. So right here we're just trying to simplify. We can't do anything with the 6, we can't do anything with negative I squared, but negative 2I and 3I are like terms, so we can add those. So negative 2I plus 3I is positive I minus I squared. Okay, step 3. We need to remember when we're dealing with imaginary numbers that I squared equals negative 1. So we need to input negative 1 into the equation, because right here we have an I squared value, so we need to put negative 1 there. So 6 plus I minus, we gotta keep the subtraction sign, and then in parentheses minus negative 1, because that's what I squared is equivalent to. And the last step, step 4, we just want to go ahead and simplify. So we have 6 plus 1, because minus a negative, 2 negatives, you have to make them positive, so you end up with 7 plus I. B. Complex numbers. 6 minus 5I divided by 3I. To start, step 1, for this problem, you want to get the imaginary number out of the denominator. So for this problem, we want to get 3I out of the denominator. But to do this, we need to multiply the denominator by its conjugate. If we remember, the conjugate of every complex number is pretty much its opposite. So the conjugate of a complex number, for example, a minus bi, is just a plus bi. So you're reversing the sign of the second term. In this case, our denominator, 3i, the conjugate of positive 3i is negative 3i. So for step 2, we just want to go ahead and multiply the numerator and denominator by negative 3i. So just write the equation again. 6 minus 5 over 3i. And again, we want to multiply the numerator and denominator of this term by negative 3i. So negative 3i times 6 minus 5i, and then also negative 3i times the denominator. Step 3, want to go ahead and distribute the numerator. And to do that, just multiply 6 times negative 3i and negative 5i times negative 3i. So 6 times negative 3i is negative 18i, and negative 5i times negative 3i is positive 15i squared. And we also want to distribute the denominator. Or not distribute the denominator, but multiply it. So we want to multiply 3i times negative 3i, which will give us a negative 9i squared. For step 4, we want to input negative 1 for all I squared values. So anywhere where we see I squared, we want to input negative 1. So in this case, we have negative 18i plus 15. We have I squared here, so we want to put a negative 1 in its place. And then on the denominator, we have negative I squared. Again, we see a I squared. We want to put negative 1 in its place. Finally, step 5, we want to simplify and reduce this fraction. So negative 18i plus 15 times negative 1. Negative 18i, we can't do anything with that. Plus 15 times negative 1 would just be negative 15. And then negative 9 times negative 1 is positive 9. And here we can actually simplify this fraction. A common multiple for 9, 15, negative 15, and negative 18 is 3. 3 goes into 9 3 times. 3 goes into negative 15 5 times. 3 goes into negative 18 6 times. So we can rewrite this up here as negative 6i minus 5 over 3. Now, in this case, we have negative 6i minus 5 over 3. And 3 doesn't go into 5, but 3 does go into negative 6i. So to simplify that, we can simply break up this term into two separate fractions. So we can have negative 6i over 3 minus 5 over 3. Right here, 3 and 6 are multiples, so 3 goes into 3 one time, and 3 goes into 6, or negative 6, twice. So we end up with negative 2 over 1 minus 5/3, but negative 2i, which is the same as negative 2i minus 5/3. And we can even flip that around and just finally write it as negative 5/3 minus 2i. (2a) Linear functions. Write then graph the equation that describes the following statement. The line passing through ordered pair 4, 3 and ordered pair 1, negative 3. So with this equation, pretty much you're trying to graph a line, and then you need to find the slope, and you gotta try to make sure that all the results that you get are correct. So let's just start with step 1. Step 1 is to use the equation of the slope with both of these ordered pairs. So if we remember, the equation of the slope is y1 minus y2 divided by x1 minus x2. It could be y2 minus y1, and if you do that, then it has to be x2 minus x1 on the bottom. But pretty much you're taking these two ordered pairs and you're using this formula to find the slope, to find the change in y and the change in x. So we start by taking our two ordered pairs. We have 4, 3 and 1, negative 3. And we assign them a y1, y2, x1, and x2 value. So the way I like to do it is I like to have my first term, which is your x term, be x1. So 4 is x1, and then 3 is y1, and then 1 is going to be x2, and negative 3 will be y2. Now that we've identified which ones will be which, we can go ahead and go to step 2, which is to input the slope into the point slope formula. Actually, I'm ahead of myself. Let's finish up with step 1. So we have these values assigned. Now we just need to go ahead and plug these values into the actual equation here. So first we take our y1, which in this case is 3, have 3, has to be minus y2, y2 is negative 3, so minus negative 3, divided by x1, which is 4, minus x2, which is 1. So if we evaluate this, 3 minus negative 3, since there's two positives, it would be 3 plus 3, so it would be 6, and then 4 minus 1 would be 3, which is just, if you reduce it, 3 goes in, 3 is a multiple of 6, so 3 goes into 3 once, 3 goes into 6 twice, so you're left with 2, and 2 is m, and m represents your slope. Now going on to the next step. The next step, now that we found our slope, is to input the slope into the point slope formula, which is y minus y1 equals m times x minus x1. So we have y minus y1, again y1 from the beginning was 3, and then we have equals m, and in this case our slope, our m, is 2, and then times x minus x1, and x1 is 4, so x minus 4. So now we have our equation in point slope form. This right here is our point slope form, and we can move on to step 3. Okay, step 3 has us distributing the right side of the point slope form and solving for y to give you the slope intercept form. So in this step we want to go from point slope form right here to slope intercept form, which is y equals mx plus b, with b being your y-intercept, m being your slope. Okay, so now we need to distribute the right side of this equation, which is in point slope form. So you end up with y minus 3 equals 2 times x is 2x, 2 times negative 4 is negative 8. And to get into slope intercept form, we have to solve for y. So we want to get y by itself. To do that, we add 3 to both sides, and we end up with y equals 2x minus 5. So this right here, y equals 2x minus 5, is our slope intercept form. This is our y equals mx plus b. Now we're on step 4. We want to go ahead and plot the original ordered pairs, which is 4 and 3, and 1 and negative 3, to graph the equation. So we have our little graph here. If we plot 4 and then up 3, that will be about here. And then our second ordered pair is positive 1, and then negative 3, so down 3. And then we would just have to go ahead and try to draw this. Try to connect the line here. Now we've graphed the line, and for the last step we want to plug in at least one random number into the slope-intercept form, which is y equals 2x minus 5, and whatever point we get from graphing, it should match this line. So we're going to put in a random number value for x, and whatever ordered pair we get should fall somewhere on this line. So we can just go ahead and set up a little chart, y equals 2x minus 5. Just set up our x and y chart that we've used before. So you got your x and you got your y. So in this case, let's start with setting our x value to 0. So you have y equals 2x minus 5. We substitute a 0 for this x, minus 5, and you end up with y equals 2 times 0 is 0, minus 5, so y equals negative 5. And when we graph this, 0, now this ordered pair we have, 0 and negative 5, just like it says right here, when we graph this ordered pair on our line, which is the line of 2x minus 5 right here, this point 0, negative 5 should fall on our line. So if we go 0, then we go down 1, 2, 3, 4, 5. As you can see, 0, negative 5 does fall on the line. So just like it says here, 0, negative 5 is a point on the line. So we know our slope intercept form is correct. And actually, just to show you that the slope intercept form is correct, we can even take our original ordered pairs. So let me see, we have 1 and negative 3. We can take 1 as our x value and plug it into the y equals 2x minus 5 formula. So you have y equals 2 times 1 is our x value, 1 minus 5. So that's y equals 2 minus 5. Y equals negative 3. And if you look up top here, our x value is 1 and our y value is negative 3. So that's right. And then if we get our other ordered pair, 4 and 3, if we put 4 as the x value and we plug that into our slope-intercept form, it'll be y equals 2 times 4 minus 5. That'll be y equals 8 minus 5, y equals 3. So our ordered pair is 4 and 3. And as you can see, 4 and 3 is our ordered pair. So we know that after plugging these values in, we know that our slope interform is correct. (2b) Linear functions. Write then graph the equation that describes the following statement. The line passing through 1, 2 and ordered pair negative 1, 3. So the first thing we want to do is we want to use the slope equation, which is this right here, which is y1 minus y2 divided by x1 minus x2, which shows us our change in y divided by our change in x. So we want to input these ordered pairs into this formula. So our ordered pairs are 1 and 2 and negative 1 and 3. The first thing I like to do is to label both ordered pairs. So let's label them y1, y2, x1, x2. So since this is the first ordered pair and this is the x coordinate right here, I'm going to label this as x1. This is the y term, first ordered pair, so I'm going to call it y1. This is the second ordered pair, So I'm going to call this one x2, and likewise the y-coordinate of the second ordered pair y2. Now that we have those set, we're going to actually plug in these numbers into the slope formula. So first thing we need is y1, which right here we can see is 2. So it'll be 2 minus y2, which is 3. So 2 minus 3. And that's divided by x1, which is 1 right here. It's going to be minus x2, which is negative 1. So negative 1 in parentheses. That equals 2 minus 3 is negative 1. 1 minus negative 1 is, since it's two negatives, you end up adding. So 1 plus 1 is 2. And negative 1/2 equals m, which is our slope. Okay, now step 2. Now that we have the slope of this equation, we need to go ahead and, just like it says here, step 2, input slope into point slope formula. That way we can find the point slope form of this line. And the point slope formula, just like it says over here, is y minus y1 equals m times x minus x1. So let's start plugging these numbers into the point slope formula. So you have y minus y1, which is 2, equals m, our slope, which is negative 1/2, and that's times x minus x1, which is 1, and right here the equation is in point slope form. Okay, step 3. Step 3 wants us to go ahead and distribute the right side of the equation, which is this right here, the right side of the equation, and it wants us to solve for y to get the equation into slope-intercept form, which is y equals mx plus b, as you can see right here. And m is your slope, and then b is your y-intercept. So we want to distribute negative 1/2 in x, and then negative 1/2 in negative 1. So we have y minus 2 equals negative 1/2 times x. It's going to be negative 1/2 x, and negative 1/2 times negative 1, since it's a negative times a negative, it'll be a positive, so it'll be plus 1 over 2. And right here we want to get y by itself, so to do that we have to add 2 to both sides of the equation. We end up with y equals negative 1/2 x plus 2.5. So this right here is our slope-intercept form. This right here is our y equals mx plus b. Now for step 4, we want to go ahead and we want to graph the equation with the ordered pairs 1, 2, and negative 1, 3. So let's start with graphing 1, 2. Go 1 to the right, up 2. So this is 1, 2. And then the next ordered pair is negative 1, 3. So negative 1, and then up 3, 1, 2, 3. So that's right about here. Then we just want to go ahead and draw our line connecting the 2 points. And we went ahead and we drew the line connecting the 2 ordered pairs. Now for the last step, for step 5, we need to find a random point on the graphed line right here. And to do this, to find this random point, we need to plug in a random number for the x of the slope-intercept form, which we saw our slope-intercept form was y equals negative 1/2 x plus 2.5 or 2.5. and our main objective is whatever point that we find, it needs to actually be on this line. It needs to be located on this line. So to do this, to find this random point, we just want to make a little chart just using the slope-intercept form. So y equals negative 1/2 x plus 2.5 or 2.5, and just make a little xy chart. So you got your x coordinate and your y coordinate. And to start, we want to find that random point. So we just got to come up with a random number for x. So let's use 2. If we plug in 2 to the slope-intercept form, it'll be y equals negative 1/2 times 2 plus 2.5. If you evaluate that, negative 1/2 times 2 is just negative 2 over 2 plus 2.5. Negative 2 over 2 is the same as negative 1 plus 2.5. Negative 1 plus 2.5 is just a positive 1.5. That's our y coordinate. Plug it into our chart. So our ordered pair here is 2 and then 1.5. So if we go to our chart, we have 1, positive 2, and if we go up 1 and up another half, we have our point right about here. And as you can see, this ordered pair, 2, 1.5, is graphed on our line like the comment we had. And just to check our original graph points, we had 1, 2, and negative 1, 3. Just to check our slope, we can plug those in. So the first ordered pair is 1, 2. We can take the x value of 1, put it in here, and then go ahead and evaluate that. So y equals negative 1/2 times 1 plus 2.5, and negative 1/2 times 1 is just negative 1/2 plus 2.5. Negative 1/2 plus 2.5 is just 2, positive 2. So 1 and 2, and that's our first ordered pair here. And then we can do the second ordered pair, negative 1 and 3. So we'll plug in a negative 1 for our x. Y equals negative 1/2. Our x value is going to be negative 1 plus 2.5. And y equals negative 1/2 times negative 1 is going to be positive 1/2. And then plus 2.5. And positive 1/2 plus 2.5 is 3. And as you can see, negative 1 and 3 is our second ordered pair here. So we know our slope-intercept form is good. 3. Quadratic equations. Solve each equation by using the quadratic formula. X squared minus 10x minus 50 equals 0. Step 1. You want to make sure the equations in standard form of the quadratic equation, which is ax squared plus bx plus c. That's the standard form. Ax squared plus bx plus c equals 0. Now, this equation, x squared minus 10x minus 50 equals 0, is already in standard form. As you can see, x squared is the ax squared portion, then you have bx, and then you have c, and it's set to 0. So the equation's already in standard form. So already in standard form. So that's good. Now we have to go to step 2. So for step 2, it just says to input the values of the standard form into the quadratic formula. And remember, the quadratic formula is negative b plus or minus the root of b squared minus 4ac all divided by 2 over a. So we just want to input the values. So for negative b, what is our b value? Our b value is going to be the coefficient of the middle term of our standard form, which is negative 10. So it's minus b, as we can see right here. So we're going to have minus a negative 10. And then plus or minus the root of b squared. And b again is negative 10. So put it negative 10 in parentheses. Minus 4a. Our a value is x. And x by itself really means we have a coefficient of 1. So our a value is going to be 1 and then times c. In this case, the third term c is negative 50. So we're going to put negative 50 for c there. And all of this is going to be over 2a. And again, a is a value of 1. So now that we inputted everything, we just need to go ahead and go to step 3, which is to just evaluate using the quadratic formula. So let's evaluate this quadratic formula. Negative times negative 10 is pretty much just positive 10. So we have 10 plus or minus. Actually, this right here, I made a mistake. It should be negative 10 squared. And negative 10 squared is going to be positive 100 minus 4 times 1 is just negative 4 times negative 50. And then 2 times 1 here is just 2. So 10 plus or minus. Keep simplifying this. 100. Now we're going to multiply 4 times negative 50 using PEMDAS. Negative 4 times negative 50 is going to be positive 200. And all of that's going to be over 2. If we keep simplifying, we have 10 plus or minus 100 plus 200 is 300. And that's going to be over 2. Alright, on to step 4. Step 4 says to simplify the value under the radical, which is this value right here, 300, if possible. In this case, positive, or the radical, or the root of 300 will simplify to 10 root 3. So let's kind of see how that works. To do that, we need to figure out what are multiples of 300. So we'd have 10 plus or minus. We would have 3 times 100, because 3 times 100 is 300 over 2. And 100 can still be simplified. 3 can't because it's a prime number. So 10 plus or minus 3 times 10 times 10 all over 2. And since we have 2 10s here, we can simply take that and move it over to the left of the radicand. So we'll end up with 10 plus or minus 10 over 3 all over 2. Go into the next step. It says to reduce the denominator with terms of the numerator if possible. And it kind of shows us how this is going to reduce. So right here, to reduce this, we have 2 as the denominator, and 2 goes into itself once, but 2 is also a multiple of 10. 2 will go into 10 5 times, and then again 5 times. So we're left with 5 plus or minus 5 root of 3 over 1, which is just the same as 5 plus or minus 5 root 3. Now, for our final step, we just have to go ahead and remember to evaluate the negative and positive part of this quadratic solution. Because again, quadratic equation is dealing with plus or minus. So we need to include that. So we would have 5 plus 5 root 3 or 5 minus 5 root 3, which can't be simplified anymore. So that's the answer. 5 plus 5 root 3 or 5 minus 5 root 3. 4. Radical equations. Solve each equation. 3 plus 2x, the root of 3 equals 5. So the first thing you need to know is for this equation you're pretty much just trying to solve for x. So we're trying to solve for x, this variable right here. Now step 2, we want to subtract 3 from both sides. Again, we're solving for x, so we're trying to get x by itself. So subtract 3 from both sides. We end up with 2x root 3 equals 2. Next, we want to go ahead and we want to divide both sides by 2 to get rid of x, the variable's coefficient. So again, we're still trying to get x, we're trying to get this by itself. So what we can do is we can divide x by its coefficient, which is 2. So if we divide on one side, we have to divide on the other side. So that gives us this 2x root 3 over 2 equals 2 over 2. But this right here reduces, 2 goes into 2 once, or when you divide it by 2 it gets rid of these, and then we have x root 3, 2 over 2 is just 1, and actually I kind of did step 4 too, because I reduced the equation right here, this part right here, and it just reduced down to this form. Now x still isn't by itself. We have this radicand, we have root 3, so we're trying to get x by itself. In order to do that, we want to go ahead and, just like it says in step 5, we want to divide both sides by root 3 to get x by itself. So we want to divide by root 3. If we divide the left side, we have to divide the right side. So that gives us x equals 1 over root 3. Now, right here, we kind of have an issue. 1 over root 3, because we have a radical, we have this radical here in the denominator, root 3 is irrational. We don't want that for our final answer, so we need to rationalize this. We need to rationalize root 3. So to rationalize root 3, we can just go ahead and, like it says here in step 6, to get rid of the rational in the denominator, it just says to multiply the numerator and the denominator by root 3. So if we multiply the numerator and the denominator by root 3, we end up with x equals 1 times root 3 is just root 3, and then root 3 times root 3 is just root 9, but root 3 is simplified, but root 9 isn't simplified. Root 9 is really the same as x equals 3. Root 9 can be simplified to like 3 times 3, and if we had 3 times 3, then this 3 can be moved to the left, and you can completely get rid of the radicand in the denominator, which was our goal. So we end up with x equals root 3 over 3. 5, absolute value. The absolute value of x plus 1 plus 2y is less than 0. Alright, in this equation, step 1, we're going to solve for y. So that's right here. We're going to solve for y, and to do that, we want to start by dividing both sides of the inequality by 2. So we can go ahead and divide the inequality by 2. If we do it on the left side, we have to divide by 2 on the right side. That gives us x plus 1, absolute value of x plus 1 plus 2y over 2, and then 0 over 2 is the same as 0. Now again, on the left side here, we're trying to get y by itself. So we have this fraction, but to help us simplify it, we can split the fraction into 2. So we have absolute value x plus 1 over 2 plus 2y over 2 is less than 0. Step 3, we can simplify 2 over 2y, which just becomes y. So we have x plus 1, absolute value x plus 1 over 2, and then 2y over 2 just becomes 1 and 1, so plus y is less than 0. Next, step 4, we want to go ahead and subtract the absolute value from both sides of the equation, and the point is to get y by itself. So to do that, we just subtract the absolute value, which is this term here, from both sides of the equation. So x plus minus x absolute value x plus 1 over 2, and then we'd have to do the same thing right here over 2, and then that just gives us x plus, oh no wait, that just gives us y is less than negative absolute value x plus 1 over 2. Now right here, just like it says in step 5, we have the equation of the inequality, and so this right here, it's not the solution, but this right here is the equation of the inequality. And at this point, you can plug this equation into the calculator to graph. You can do this at this point because y is isolated. Moving on to step 6. With an inequality, there's lots of points that are not on the line of the graph. Let's say that again. With an inequality, lots of points that are not on the line of the graph are also solutions, as they make the statement of the inequality true. However, focus on making the inequality an equality, which will yield statements that are located on the actual line or rays of the inequality. It's easier to graph the equality that corresponds to the inequality. That's pretty much just saying that with an inequality, you might have points above or below the line that can make the statement true depending on what the actual inequality says. But in this situation, to help us graph it and find the different points to help us graph the inequality, it's best to actually make the inequality an equality. So we can do that by just taking the equation and making it y equals negative x plus 1 all over 2. So now instead of being an inequality like here where we have the inequality sign, it's an equality. Alright, so to graph this equality, we need to find the vertex of this right here, which we're going to call star prime, and we're going to call this one star just to separate the two. So we'll call this star prime, and this is the equality of the inequality, because this right here, star prime, is the quality of this inequality right here. Now, to solve this, we're pretty much just trying to find the vertex. So right here it says graph star prime, or graph this equality. Find vertex of star prime. Finding the vertex of a parabola is a different method than finding the vertex of an absolute value. Because like with a parabola, you do like b over 2, something like that. You don't do that here. The vertex of an absolute value occurs when the value of the absolute value is 0. So we need to find the vertex value. To find this vertex value 0, you need to plug in the x value that, once evaluated, would make the absolute value itself equal to 0. So we're trying to find the vertex here. So right here we have y equals negative x plus 1 over 2. The absolute value is it's always positive. It's always positive or 0. So we need to find a value that will make this absolute value equal to 0. And specifically, we need to find the x value. So we can make a little chart again. You got your x, you got your y. Okay, so what plus 1 would make this equal to 0? Well, negative 1. Because if you have y equals negative absolute value negative 1 plus 1 over 2, you'll get y equals negative 1 plus 1 is just 0, and that's just over 2. So once you evaluate this, y equals 0, so you plug that in on a little chart, and right here, negative 1, 0, we have the vertex. We have the vertex for our equality. Now, the next step, step 8, now that we have our vertex, is because we're dealing with inequalities, inequalities have a negative value and a positive value. So we need to pick an x value that's less than the vertex. So we need an x value that's less than negative 1, and then we need an x value that's greater than the x value of the vertex. So we need a value that's greater than negative 1 and less than negative 1. And we need to plug that in. So what's less or what's greater than negative 1? Well, how about 1? And if we plug that in, y equals negative absolute value of 1 plus 1 over 2. Y equals, let me see, 2 absolute value 2 over 2, y equals negative 2 over 2, y equals negative 1. So this would be 1 and negative 1. Then, so this was our point 1, which was greater than negative 1. Now we need a point that's less than negative 1. So how about negative 2? So if we plug in negative 2 into our equality, we have y equals negative absolute value of negative 2 plus 1 over 2. Y equals negative 2 plus 1 is just negative 1 over 2. And we got to be careful here because negative 1, once you take out the absolute values, negative 1 becomes positive 1, and then when you combine it with this negative, then it ends up being negative 1 again. So you end up with y equals negative 1 over 2. So negative 1/2 gets plopped in here. And now, as we can see, now we have 3 points. The vertex, we have the point less than, which was the negative 2. It's less than negative 1, which is our vertex right here. And then we have the point greater than the vertex x value, which is our 1, because 1, the x value of 1 is greater than this x value of the vertex, which is negative 1. So now we want to go to step 9. It says draw a dotted line to graph the inequality. You use a dotted line since the graph does not include all of the points on the graph. If it's a less than sign, it is a less than sign. If it was a less than sign where the inequality was less or equal, then you would draw a solid line for the graph. So we want to pretty much just graph the vertex and the 2 points of this inequality. Okay, so we want to graph the points. Our first point is negative 1 and 0, our vertex. So negative 1, 0. This is going to be our vertex. And then, and remember, like with an absolute value, the vertex is just the point where the other 2 lines go off from. It's kind of like the bottom of a V. That's your vertex. Now we need to go ahead and graph the other points. So we have 1 and negative 1. So 1, negative 1, which is right here. And then we have negative 2, negative 1/2. So negative 1, negative 2, negative 1/2, so right about in the middle. And then we need to remember it says draw a dotted line to graph, because if we remember in the beginning, our equation is a inequality and it's a less than sign. So since we have a less than sign, like it says here, if it's a less than sign, we need to use the dotted line. So we need to do like a dotted line to draw the line for this equation. If it was less than or equal to, this would just be a solid line, but it's not. All right, now step 10. It says if the inequality is less than, which is what we have, a less than inequality, then you shade the region below the line. So this is the line right here. So because this is a less than, we need to shade this region right here. Everything below the line has to be shaded. Now for step 11, last step, we need to pick a point in the shaded region and see if it makes the inequality a true statement. So here's our shaded region right here. Let's pick 0, 5. Let's pick this point right here in the shaded region. So we need to make a little XY graph, and let's do 0 and then -5, and our inequality is just y is less than -x plus 1, and all of that's over 2. And we just plug in the 0 value to x and then the -5 value to y. So -5 is less than x is 0 plus the absolute value of 1 all over 2. And if we evaluate this, it's -5 is less than 1 over 2. -5 is less than just -1 over 2. So -5 is less than -1/2. And this is a true statement because a -5 is less than -1/2. So this is a true statement, or this is true. Thus we have shaded the correct part of the graph. So this is kind of a way to check, because we already shaded this part of the graph below the line because it was an inequality, or because it was a less than. But then by plugging in this random point in the shaded region and getting a true statement right here, our true statement, we know that we did indeed shade the correct part of the graph. Composition of linear functions. 6a. Find f of g of x. And fx is equal to fx plus 4, and g of x is equal to 3 minus x. So the first thing to do is to rewrite f of g of x into this shorthand, just to kind of get some practice. So you have f of g of x, and again, this is how you say it, f of g of x. And we would just want to put it into the other form, which is f of g of x. These right here are the same thing, just a different way to write it. So once you've done that, then step 2 is to go ahead and input the gx value of 3 minus x into the function f of g of x. So this is f of g of x, and as we can see up here, g of x equals 3 minus x. So this portion right here, we want to insert this value 3 minus x. So we would just end up with f of 3 minus x. And if you go to step 3, we can see that f of g of x becomes f of 3 minus x, which is what we have right here. So now it says we want to set this new function of f of 3 minus x equal to the original function value, which is fx plus 4. So our original function value was fx plus 4. So we want to set f of 3 minus x equal to 5x plus 4. Now another step of that is, once we have 3 minus x, we want to substitute right here this x value. We want to substitute that with our 3 minus x value. So f of 3 minus x equals 5, 3 minus x in parentheses plus 4. Then the last step, we just want to distribute the right side of the equation and simplify. So to distribute this, we'd have to multiply 5 times 3 and 5 times negative x, and then to simplify. So f of 3 minus x equals 15, 5 times 3, 15, 5 times negative x is negative 5x plus 4. Keep simplifying. 5 of 3 minus x equals 15 plus 4 is 19 minus 5x, and that's your solution. Solution is f of 3 minus x equals 19 minus 5x. 6. Composition of linear functions. Find g of f of x, f of x equals 5x plus 4, g of x equals 3 minus x. So step 1 is to write g of f of x into g of f of x just using this different format. So let's just do that. G of f of x, make it look pretty now, into g parenthesis f parenthesis x, make sure it's in closed parentheses. And step 2 says to input the fx value into the g of f of x function. So here our fx value is 5x plus 4. So we want to do g and then 5x plus 4. Okay, step 3 says set the g function as g fx. Set g function as g of fx of. Set the g function as g of 5x plus 4. Then input on the right side of this function the gx value 3 minus 6. Then for this x value, substitute the f of x value 5x plus 4. So let's do one at a time. It says first, set the g function as g of 5x plus 4. So we'll just have that, g of 5x plus 4. And then on the right side, it wants the gx value 3 minus x. So for that, we have to do is we would have 3 minus x. But then what we need to do is for the x value, substitute the fx value 5x plus 4. So this value right here, 5x plus 4, we have to substitute for this x value right here. So it'd be g of 5x plus 4 equals 3 minus, in parentheses, 5x plus 4. And we can just go ahead and just distribute out this negative sign onto both of these terms. So we end up with g of 5x plus 4 equals 3 minus 5x minus 4. And if we combine like terms, which is 3 and negative 4, we end up with g of 5x plus 4 is equal to 3 minus 4 is just negative 1 minus 5x. And that's the answer. And you could read that as g of 5x plus 4 equals negative 1 minus 5x. Oh, and also for clarification, this is problem 6b. 6b. 7. Synthetic division. Given a polynomial and one of its factors, find the remaining factors of the polynomial. Some factors may not be binomials. Right here we got x to the third minus 4x squared minus 11x plus 30, and that's divided by x plus 3. So step 1, we want to take the opposite value of the number you're dividing by. So in this case we're dividing by x plus 3. So you want to take the opposite value of 3, which is negative 3, just like it says. The number you're dividing by, positive 3, you need to put negative 3 in the upper left corner. So to set up the synthetic division, we have the upper left corner, we have negative 3 like this, and then step 2 says write all of the coefficient values in the numerator in separate columns. So our first numerator value, x to the third, is pretty much 1x, so we put 1 here. And then our next coefficient is negative 4, then negative 11, and positive 30. Okay, now step 3 says bring down the degree of the polynomial value. In this polynomial, the degree of the polynomial is the highest exponent value, which is x to the third, and which is x to the third, and the coefficient value of x to the third is 1, so we have to bring 1 down below this line. Bring the 1 down here, so we got 1. Now that we've done that, which would be doing the negative 3 is kind of step 1. Bringing down the 1 is kind of, we're actually putting all of these coefficient values on the top column. Is kind of our step 2. Bringing down the 1 value is like our step 3. And our step 4 right here is to multiply negative 3 by 1. The result's going to be negative 3. So we take this negative 3 in the upper left corner and we multiply it by this number below the line, which is 1. So it's negative 3 times 1, which is just negative 3. And then we take that negative 3 value and then we insert it on the next column right here. So then and yeah, that's step 4, the multiplying. So now moving on to step 5, we need to put negative 3 under the second coefficient column, which is what we did right here, under the second coefficient column. Then we need to add negative 4 and negative 3. So we need to add these two terms together, and this is kind of our step 5, and that just gives us negative 7. And then we kind of keep doing the same procedure. So we take our top left corner value, negative 3, and we multiply it by negative 7, and that's going to give us 21, positive 21. We take that positive 21 and we put it below the third column. So it's negative 11 plus positive 21, which is just 10. Then we do the same thing, 10 times negative 30, which is negative 30. 30 minus 30 is 0. Now, for step 6, the final step, it says starting with a term with the second highest degree of the polynomial, plug in all the values. So the degree of the polynomial was x to the third here, right here. So start plugging in with x to the second. So it's pretty much saying that our answer is going to start a degree below the degree of the polynomial. So since the degree of the polynomial is x to the third, our answer is going to start with x raised to the second power. And then we just need to take our values on these bottom columns and we need to plug them into the different x values. So x squared, which would be pretty much 1, bringing the 1 over here, and then we have a -7, so it's a -7, and the exponent value below 2 is just 1, so in this case it's just x, so -7x, and then, which is pretty much like x to the first, and then below the x you just have a coefficient like right here, so -7x plus 10, and in this case the 0 right here, the 0 right here is the remainder, and like we put here, 0 represents the remainder. A remainder of 0 means there is no remainder, so we don't have a remainder here. We don't have to worry about that. And also another note, when you plug in these values like -4, -11x, you have to remember to keep the negative sign. So if these second and third terms are negative, you gotta put them in here as negative. But yeah, there you go. You have x squared minus 7x plus 10 is your answer. And another way, or a way to check your answer, you could simply do long division for this equation, which would just be x plus 3, x to the third minus 4x squared minus 11x plus 30. And not to get too complicated with this, but to do this you would just say what times what is x to the third, it'd be x to the second, like x times what is x to the third, and then you'd have minus, it'd be x to the third, 3 times x, 3x squared is just plus 3x squared, and then you distribute the negatives, so it'd be minus x to the third minus 3x squared minus x to the third power, x to the third would cancel out. You have negative 4x squared minus 3x squared, which is negative 7x squared, and you'd have minus 11x that you just bring down, and you say to yourself, negative x times what is negative 7x squared, and it's just negative 7x times x is negative 7x squared, so minus negative 7x squared, and then you say 3 times negative 7x is just negative 21x, and a negative and a negative end up being a positive, so it's positive 7x squared. Oh, and this would also be a negative and a negative, so this would be this would cancel out, and then this would just be 10x yeah, 10x plus 30, and then you just have to do x times 10x, 10x, or x times what equals 10x, and it's just plus 10, and then 3 times 10 is just, so wait, you'd have minus it'd be 10 x, and then it'd be 3 times 10 is 30. Right here, 3 times 10 is 30. And then you have 0 and negative distributed. It'd be 30 minus 30, and it'd be 0, and that's your remainder. So this is just using long division to check that your answer is right. Because as you can see, x squared minus 7x plus 10, x squared, x to the second power minus 7x plus 10, they're the same. 8. Rational functions. Solve each equation. 4 over x minus 1 equals x plus 1 over 12. Alright, step 1, we're trying to solve for x. So we're trying to solve for x in this equation. We want to find the LCD of both terms. In this case, the LCD is 12 times x minus 1. You got denominator of 12, denominator of x minus 1. The easiest way to get the LCD is just combine them by multiplying. So 12x minus 1 is our LCD, so let's put that in there. If you have x minus 1, then you have to multiply this side by 12, the numerator and the denominator. And then on this side there's a 12. We need the x minus 1, so we have to multiply this side by x minus 1 on the numerator and the denominator. So 12 times 4 is just 48. Actually, that would be step 2. So we're just multiplying the terms on the numerator and the denominator. We already got the LCD. And even maybe this is going into number 3. Evaluate the numerators on both sides of the equation. The numerator is just 12 times 4, and then distributing this out. So 12 times 4 is 48 over 12 x minus 1, and then equals x plus 1 times x minus 1 is a difference of squares. And when that happens, you end up with just like x2 minus y2. So this is going to be x squared minus 1 squared over 12 times x minus 1. Step 4, since both denominators are the same on both sides of the equation, you can get rid of them. So in this case, 12 times x minus 1, 12 times x minus 1 are both the same denominators. We can just get rid of them. And even right here, I probably should have finished evaluating this, because this denominator, if you evaluate that, negative 1 squared would just be minus 1. So we should be left with 48 equals x squared minus 1. Now for step 5, again we're solving for x, so we want to subtract 1 from both sides of the equation. We're trying to get x by itself, so plus 1 plus 1. This right here should actually say add 1 from both sides of the equation. So if we add 1 on both sides, we end up with 49 equals x squared. And then heading over to step 6, x squared needs to be made just x. Again, we're trying to solve for x, so we need to get rid of this exponent. To do this, we got to square both sides of the equation. We put a radical over both terms and simplify. So So you have 49 equals x squared. Just put the radical over each term on both sides of the equation. The root of 49, I mean, it's just the same as 7 times 7, which is just 7, equals x squared just equals x, because it's really x times x. And then that simplifies to x. So x equals 7 or negative 7, because you can have negative 7 times negative 7, which can equal positive 49, or you can have positive 7 times positive 7, which also equals positive 49. So your answer is x equals 7 or negative 7. And you can see that right here, because right here it's telling you to simplify. It's telling you to simplify these radicals, which we did. And like it says, since both 7 and negative 7 squared equal 49, then this right here, x equals 7 or negative 7, is your answer. Number 9, exponential and logarithms. Solve each equation or inequality. This is 9a. 25 to the power of 2x equals 125 to the power of x plus 2. Step 1, our goal is to solve for x. We are solving for x. So to begin with, we want to go ahead and rewrite these different terms. We need to rewrite 25 to 2x and 125x plus 2. We need to write them with their roots. So the root of 25 squared ends up being 5 to the second, or 5 squared times 2x, because 5 squared is 25. It's the same thing. Do the same thing for 125x, and you get 5 cubed, then x plus 2. Now for step 3, we multiply or distribute the exponent value of the root term on both sides of the equation. So pretty much you're just multiplying this exponent value by these terms. So 5 cubed times x and times 2. So 2 times 2x, you end up with 4x equals 3 times x, you end up with 3x. 3 times 2 is 6, so 5 raised to 3x plus 6. And then for step 4, it says you can drop the root value 5 of both terms and set the exponent values equal to each other. So right here we can drop the 5s from both terms. That's also called the 1-to-1 property. Since we have a value of 5 on both sides, we can get rid of it. So that leaves us with 4x equals 3x plus 6. Now step 5, it just says solve for x. So to solve for x, we would just subtract 3x from both sides. That gives us x equals 6. And it just asks us to check our answer. You know, we can always plug in 25 2 times 6 equals 125 6 plus 2. 25 2 times 6 is 12 equals 125 to the 8th power, and you could just multiply the two. Also, it's worth noting that y equals log bx, which means b raised to the y power equals x. This is logarithmic form. This right here is exponential form. And to say this, you would say, to speak it, you would say log base b of x equals y. That's for this statement here. And then for this statement, you can say b to the y power equals x. Number 9b. Exponentials and logarithms. Solve each equation or inequality. 5 raised to the 2x power is less than 125 raised to the x minus 5th power. For this equation, we're going to be solving for x, and we need to find the power base of 125, which is 5 cubed. So we have 5 raised to the 2x power. 125, the power base, ends up being 5 cubed in parentheses raised to x minus 5. Step 2, we're going to distribute the exponents. 5 to the 2x you can't distribute, but 5 cubed you can distribute. 3 times x and 3 times negative 15, so you end up with 5 3x minus 15. Step 3, use the 1-to-1 property to get rid of the base 5 on both terms on both sides of the equation. 1-to-1 property says you get a 5 on the left side and the right side, you can get rid of it. And that just leaves us with the exponents 2x is less than 3x minus 15. At this point, we're just solving for x. So minus 15, we're just solving for x. So to get x by itself, step 4, we want to subtract negative 2x from both sides. So negative 2x minus 2x, we end up with like 0 is less than x minus 15. And then finally, to get x by itself, we can just add 15 to both sides of the equation. So just plus 15 plus 15, you have 15 is less than x, or x is greater than 15. Nine C, exponentials and logarithms. Solve each equation or inequality. E raised to the 4x power equals 120. Step 1, since you see the Euler function, or the Euler function, which is this right here, the Euler function, then you must take the natural log of both sides of the equation. E raised 4 to the x equals ln 120, which becomes ln e raised to the 4x equals natural log 120. So when you see the Euler function, you just have to put a natural log right here on both sides of the equation. So natural log parenthesis e for x, ln 120. Now step 2, since ln e is 1, then ln e for x becomes just 4x times ln of 120. So really right here, ln e right here is just 1, which is 4x. And when you have the power raised, you try to bring it to the left of the equation, so this just ends up being 4x, and you have 4x equals ln 120, and then that's kind of step 3 right here. And then step 4, you just go ahead and solve for x. So solving for x, you can just divide it by 4, and x equals ln 120 divided by 4. Number 9D, exponential and logarithm. Solve each equation or inequality. The natural log ln times x plus 3 minus 5 equals negative 2. Step 1, we're going to solve for x. And to begin, we'll add 5 to both sides to try to get x by itself. We end up with natural log x plus 3 equals negative 2 plus 5 is positive 3. Step 2, want to raise e on both sides. On the left side, ln raised to e equals 1. So if we have e and then ln x plus 3, and then we raise to e on the right side, it's e cubed, because this 3 ends up becoming an exponent. E to ln is just 1, x plus 3 equals e to the third, and then this just moves to the left, so x plus 3 equals e cubed, and we just want to go ahead and, like step 3 says, just solve for x. So minus 3, x equals e cubed minus 3. And just remember, e raised to ln equals 1. And that's what happened here. Application. This is 10A, by the way. 10A. Carbon dating. Use the formula y equals a times e raised to the negative 0.00012 t power, where a is the initial amount of carbon, negative 14, t is the number of years ago the animal lived, and y is the remaining amount after t years. A. How old is a fossil remain that has lost 95% of its carbon-14? So, to try to figure this out, we need to just we need to think about what they're asking. They want to know how old is a fossil remain that has lost 95% of its carbon-14. So there's some sort of fossil, some sort of dead animal that has some sort of chemical carbon-14 in it, and it's lost 95%. So what are our variables? Well, it says right here, it talks about t, it talks about y. So it gives us a few of the variables. Alright, let me see. Define variables. A is the initial amount of carbon 14. Carbon negative 14. So our formula, let's write down our formula. Y equals AE raised to negative 0.00012 t power. And okay, so A is the initial amount of carbon negative 14. So the initial amount of carbon negative 14 in an animal would have to be all of it, which would be 100%. So A equals 1, and 1 represents 100% of the carbon 14 that was in the fossil. And then we have Y, which is the remaining amount of carbon 14 after t years. So Y is the remaining amount. And right here it says the fossil lost 95% of its carbon 14. So if you represented 95% as a decimal, it'd be 0.95. And how much is left from our A value, which is 100? Well, it'd be 0.05 because there's 5% left. And 0.05 represents the 5% remaining carbon 14 emission. Now that we kind of define those variables, what we're trying to find is t. We're trying to find the number of years ago the animal lived. Because see right here, it's asking us how old does a fossil remain. It's telling us about how much carbon 14 it has or doesn't have, but we want to find the age of the fossil. So that's our goal. Step 2, define A and Y values. Plug these values into the equation. We already know A equals 1 because A is 100% of the total carbon 14. And we know Y is 0.05% because, or 0.05, which represents 5%, because we know that 95% of the carbon 14 is lost, and then there's only 5% left. So we just plug these Y and A values into our initial equation right here. We can just plug in these values. So Y is 0.05 equals A is 1, and then we have E, which is our Euler function, raised to the negative 0.00012 t. Now for this equation, we want to go ahead and take the natural log. For this equation for step 3, we want to go ahead and take the natural log and put it on both sides of the equation. And we're doing that because remember we have this Euler function there. We have the Euler function here, and this is actually 1. So we have ln natural log 0.05 equals natural log E raised to negative 0.00012 t power. And we already know that natural log ln e is just 1. So we'll have this equal to, so we'll get rid of that because this would move to the left of the natural log. You would end up with negative 0.00012t, and then you just go ahead and look at step 4, and step 4 just wants us to solve for t, so we just need to divide this coefficient in front of t, which is negative 0.00012, divided by both sides, negative 0.00012, and we end up with t equals negative ln 0.05 over negative 0.00012. And actually, if we go to the last step, step 5, and we input this information right here, we input all this into a calculator, and we just press enter, it's going to calculate our t value, and our t value ends up being 24,964.4, and our t is, if we look up here, it's number of years, so 24,964.4 years is the age of a fossil that has lost 95% of its carbon 14. And as you can see right here, we're answering the initial question. Application. Carbon dating. Use the formula y equals a times e raised to the negative 0.00012t power, where a is the initial amount of carbon 14, t is the number of years ago the animal lived, and y is the remaining amount after t years. This is 10b. How old is a skeleton that has 95% of its carbon 14 remaining? So we're looking at a skeleton, bones, and we want to know how old it is if most of its carbon 14 remains, if 95% of its carbon 14 remains. So let's start with step 1, defining the variables. We know that a is the initial amount of carbon 14, which a is 1, which represents 100%. So the skeleton initially had 100% of carbon 14, so that's what we're going to end up putting into our y equals a times e formula. Then we have t, which is what we're solving for, which is the number of years ago the animal lived. This is t in our formula. And again, they're trying to find the age of the skeleton, so that's solving for t. Then you have y, which is the remaining amount of carbon 14 after so many years. Again, just like it says here, t is what you're solving for. So you're trying to find out how old the skeleton is that has 95% carbon 14 remaining. y is 95% because y is the remaining amount of carbon-14 after so many years. It says right here, it gives us a y value. It says it's 95%. If we represent that as a decimal, that's 0.95. So now let's plug the y and the a values into the equation. So our equation, let's just write it again, y equals ae raised to negative 0.1230 Our y again is 0.95, which is representative 0.95%. Our a value is 1 because our 1 is representative of 100%, which we talked about right here. And yeah, you just have 1 times e and then raised to negative 0.00012t. So we have the equation. Now step 2 is 1 times e is just e, so get rid of the 1. So we'll have 0.95 equals just e raised to the negative 0.0012t%. And again, because we have the Euler function, we want to take the natural log on both sides of the equation, and this will get rid of the e on the right side of the equation. So if we do ln 0.95 equals ln e raised to negative 0.00012t, doing this natural log will get rid of this e. So you'll end up with ln 0.95 equals negative 0.00012t. And now, as far as simplifying goes, for step 4, we want to divide both sides by this number, by negative 0.0012. And again, we're trying to solve for t, so if we divide by this amount on both sides, then we can actually go ahead and get t by itself. So we'll end up with t equals ln 0.95 over 0.00012, and actually it's a negative, don't forget the negative, got to carry over the sign, so this is negative ln 0.95 0.002. So just like it says in step 5, if we input this equation right here into our calculator, if we plug that in, what we're going to get is our value for t, and t ends up being equal to 427.444 years, which is the age of a skeleton that has 95% of its carbon-14 remaining. And that right there, 427.44, is your final answer.